because it's the Internet Explorer for macOS. Unfortunately, I don't have a Mac with me, so I couldn't do it. But the code can be found on my website, and if you have a Mac and you try it against your Mac, i.e. your Mac, you'll find a heap overflow in there. So, how to start with Spike? Basically, Spike has a sort of a scripting language, and the way you usually start with, if you got an unknown protocol, is you sniff it, and then just take the binary dump you get from Ethereal and use the S binary. And then you start looking through the binary code and see if you can recognize some integers or string fields or whatever. And you replace them with calls like sword and xdr string, and it's got like a whole range of other functions as well. And then you find the lengths and you mark the blocks beginning and end, and then try to see if it still works, because if it doesn't, you kind of fucked up somewhere. Right, that's basically how you do it. You can just you can just call a loop there, and then start fuzzing and just let it run until something breaks. This is basically a slide I took from Dave Vitale's presentation at Black Hat a couple of years ago, because this is the essential stuff you need to start with Spike. Right, this is another thing. A guy called Tom Ferris made a small Spike script for RDP, which is the Remote Desktop Protocol for Windows. And he ran it against Windows and got a cool bug out of it. And the very interesting part is that Windows XP Service Pack 2 comes with a firewall, which is on by default, and it's got everything, all incoming stuff filtered, with the exception of RDP. So that's kind of, even though the firewall's on, it's filtering almost everything, you can still do a denial of service against the Windows box with this. Right. Yeah, the other thing is Spike by default does not work on macOS. I wanted to get it to work on my macOS and came to the conclusion that most of the code, pretty much all of the code, works on macOS. Because it was initially written for Linux, and so far it only compiles on Linux. And the only thing that you have to do if you want to get it to work on macOS is change some of the arguments to the linker, and then change the LD library path to dy LD library path, and comment out LDL RPC. And then Spike just compiles on macOS, and you can do whatever you want to do with Spike on macOS, and you're not just restricted to using Linux. Right, so that was Spike. The next fuzzing framework is Peach. It's written in Python. It's written by a guy called Michael Eddington. He developed it during PH Tutorial, I think last year or the year before. Most people are very lyric about it and say that documentation is so wonderful. I don't really agree there. I mean, there's a lot of documentation, but it's all auto-generated from comments inside the code. And the thing with comments inside code for documentation is that if you're not very well aware that it's comment for documentation, and you don't put a lot of effort and thought into it, it's more comments that document your code and aren't exceptionally useful if you don't have the code sitting right next to your comments. So that's why I don't really like the documentation in Peach. The other thing that annoys me a little bit about Peach is that it's got a whole range of APIs to generate a lot of cool things, but like a lot of the APIs are there to generate valid data. It can do URL encoding, it can do encryption, compression, checksumming, all sorts of these things, but it does all valid stuff, And because it's a fuzzer, you want to create invalid data. So, I mean, obviously it's got some APIs in there to create invalid data, the normal stuff, strings and integers and stuff. But the cooler things, like compression and URL encoding and stuff like that, there are no hooks to create malformed data. So that's kind of the thing I miss in Peach. Besides that, it's a wonderful fuzzing framework. The difference between Peach and the other ones I covered is that Peach does a lot more than just network fuzzing. It can fuzz APIs, it can fuzz files, it can fuzz COM objects, it can fuzz pretty much anything. Recently, Michael Eddington released Peach.net and Peach.c, which you can use to fuzz .NET stuff, and you fuzz anything written in all APIs from C. Right, I don't have a slide of stuff I broke, because apparently people aren't keen on telling the world what some of the things they found with Peach. It's a cool framework, though. You should definitely check it out. Right, this is the documentation from Peach. But yeah, so it's all auto-generated. I'm not a big fan of this documentation, so maybe some people are, but I don't like it that much. Right, this is one of the sample scripts in Peach. Basically, this is a sample script to show you how you can do COM object fuzzing. So yeah, if you read documentation, all of this makes sense. Yeah, or if you read documentation and toy with it a bit, it makes sense. Right. The next fuzzing framework that I want to cover is the protocol-independent fuzzer, which is written by a guy called Matthew Franz. It's not a fuzzing framework, unfortunately, and this really sucks, it's not available to the public. I've never used it either, but Matthew Franz in 2004 made a presentation for Black Hat talking about doing some examining the security of BGP and how it's implemented in several routers. And throughout the slides, you'll see a lot of cool things that he does with his fuzzer, and he'll go into some detail of how the fuzzer works, but it's never been released. And so I emailed him about it, said, is it ever going to be released? And he said, he would have loved to, but Cisco management didn't like it. So unless you work for Cisco, you're not going to see this tool ever, unfortunately. From the slides, it says that it found 4 or 5 BGP-specific implementation bugs. So that's pretty neat. Yeah. So the next one is the Mangle Me fuzzer. Right. This is written by Michał Zalewski, and this was done somewhere last year, and probably everybody knows it because it got slashdotted. Basically what it does is it generates something that looks like HTML, but is very, very broken. The code itself is pretty clean. The Mangle Me code, it's easy to extend it. He's got a demonstration of Mangle Me code on his website, which is mangle2.cgi. Actually, you're supposed to go to mangle.cgi, which doesn't do anything, but it gives you a big honking warning saying, if you proceed, things might go very wrong, files might get deleted, your box might crash, and whatnot. And then Mangle2 is the actual tool which gives you a demonstration, which just start fuzzing your browser. And if you're unlucky, or if you're lucky, I don't know, your browser will break. So the things that Mangle Me broke were like pretty much all browsers that ever existed broke on it. Yeah. And then Andy made a port to Python. And he changed a few things, and he made it a little bit smarter than Mangle Me was. And so a few minor modifications, and he fuzzed the now very famous iframe bug in IE and then led to some worm. The thing with these tools is that they're just scratching the surface. There's so much more that you can do with browser fuzzing. And also just the HTML part, what Michał Zalewski did is he took the most common tags and most common attributes and started fuzzing those. I made a modified version where I just took the HTML4 specification and I put all the tags in there and all the attributes. And if you run it again, you get some new bugs in IE, some new bugs in Firefox, and pretty much all browsers out there. You can find that tool, which is basically an extension of HTMLer. On my website, there's a link to it at the end of the slides, and I'll give a slight demonstration of some of the things I've generated, and you'll see Firefox die in a couple of minutes. Right, but first, so some more stuff about HTMLer. This is, so Andy fuzzed the thing, and he posted it to, I think, full disclosure, and then Skyline examined it and said, basically you get to smash an instruction pointer. Okay, so that's code execution, obviously. Right, so, right. Let's see. This is Firefox. And because, yeah, I've generated these before, because if you generate them, sometimes it takes a while to hit something that breaks. But this is what the new, so this is, so this is, you can see this is 107, which is not the latest one anymore, but it was a couple of weeks ago, because I think 1.5 is released these days. So, but this one's a pretty recent one, so all the bugs that were found with the Mangle Me fuzzer, they were fixed. So this is the extension I made to HTMLer, and I think this one should. Give it a second. Yep. And voila, there. And it basically crashed, and you can send stuff to Mozilla. I think this one's a no-pointer reference, but there's another one in there where you get to smash a function pointer. Yeah, some basic details in there. You know, basically the stuff you need to see what's going on. You know, if you make some small modifications to HTML, you can still find new bugs that, oh, bug. I'm not network connected, so. You know, you don't want to give people your bugs before you got a cool exploit, you know. The next tool is Mangle, which is a very, very small piece of code that I made, yeah, about a year ago. And it's only 60 lines of C code. And what it does is it takes a file, and you give it a header size. Like, let's say it's a page long. And what it'll do is it'll take 10% of the header size, and then use that in a loop, and then randomly choose an offset inside header, and just randomly change a byte, and have that byte biased towards the highest bit set, because you know you want to try and trigger some sinus bugs, things like that. This is basically, you know, the kind of Unix way that I did it. You know, they keep it simple, because in order to effectively do things, you'll have to use a bash script to have a loop and stuff like that. Right, and these are some of the things that I found with it, and I'll give you a demonstration of some PHP bugs. Basically, because my original Mangle tool is not the one I'm going to use, but I made a port to Python where it generates HTML as well, and then just points the HTML to an image file, which I used Mangle on. And wait. Should be one of these. Nope. Right. So this is the test.php is basically, you know, it's going through all the stuff I've made with the Mangle tool, and then if you so this is the little script there. If you can read PHP, or even if you can't read PHP, it's fairly trivial code. So basically, it goes over a range of files and sees if they're JPEG files with EXIF data in it. It'll try to parse them, and if you run it now. Just wait a second. Well, right there, possible integer overflow, and the process stopped. So, and the EXIF code in PHP isn't that wonderful. You've got a couple of other very nasty stuff in there. Right. So that's, but really, the Mangle tool really kind of took me by surprise, because it's the most trivial thing you can ever imagine, and like everything breaks on it. Right. So this is some of the things I fuzzed with it, and some of the images you get, and you know, some kernel oopses and seg faults, stuff like that. Right. Another one I made is a very, very small system call fuzzer. System calls are basically, if you don't know what system calls are, they're basically a service that your kernel provides to you. And you can just tell your kernel, I want to do that service, and give it some arguments. And if your arguments are valid and you're allowed to do that system call, the kernel will do that for you. Oops, damn. What I've done basically is I've generated random system calls and then given it random arguments, you know, like pointers that point to kernel space, or invalid pointers, you know, null pointers, or pointer to some data where I put to some piece of memory where I've put random data, you know, stuff from def random, and I just fed it to the kernel. And obviously, there are some system calls that you want to ignore because they interfere with fuzzing. You know, exit's obviously one. You know, you don't want your fuzzer to stop. You want it to continue until you get a kernel panic. Some others are fork, because it's very annoying when you've got a fork bomb while you're fuzzing. And there are a couple more. You know, you got some things in there that sleep indefinitely, things like that. So you want to have a list of things that you don't want to fuzz, and besides that, everything else is fine. So usually this results in a kernel panic or on Linux an oops message. And I think, yeah. So it broke SCA Unix where, you know, and I'll give you a demo of this in about 2 minutes. It breaks, you know, easily, and the panic's kind of neat though. And then macOS obviously broke, because macOS breaks and everything. Right, so this is,